functions, composite functions. So a composite function is basically a function that's composed of several parts. So if we look at this image here, it's like taking two separate functions. We have an input going into function g, and we get an output. We then take that output from function g and we input it into another function to get another output. So there's different parts within the function itself. So for example, if we look at h of x is equal to x squared plus 1, well, the first thing we're doing to this function is we're squaring it, and the second thing we're doing to it is we are adding 1. So we could actually separate it into two different functions. In other words, we can decompose it. So we could actually say, let f of x be the function x squared, and then the output of that function would be our input in g of x. So in other words, the next thing we would be doing is we'd be taking that answer, so we call it our input into g, so we'd call it x, and then we add 1 to it. So in other words, we would say that h of x, x squared plus 1, could actually be written as the function g after x. So in other words, we would be adding 1 to our output from the function f of x. Same with this example over here on the left hand side. We could take an input x, which let's say for example would be 3. We could input into the function x squared, which would mean that we'd get an output of 9. We could then take that output of 9 and put it into our x plus 1, and therefore we would get 10. So in other words, if we did g after f of x, we would get the answer 10. And of course we could just put it straight into the function x squared plus 1, which would give us 3 squared plus 1, which is of course 10. So let's take a second example here. If we have 6x cubed plus 3, well, the order in which we're doing our decomposition is really, really important. So what is the first thing we have to do here to our function? So of course it's that we are going to cube it. The answer in step 1 would become the new input in the next function. So in other words, what am I doing next to my input? So I've cubed it first. Well, the next order would be to multiply it by 6. So in other words, the answer in step 1, in other words, the answer we get when we cube our value, would become the input in the next function where we multiply by 6. The answer we would get after multiplying by 6 then has to be then added to 2. So in other words, our order of operation here is x cubed, multiply it by 6, and then add 2. So we can decompose 6x cubed plus 2 into 3 separate functions because there are 3 things we're doing to our input here. So we could say let g of x be the first function, which is x cubed. The output from cubing our x value would then have to be multiplied by 6. So we would say let x be our input. We are going to take that input and multiply it by 6. The output we get from multiplying by 6 then becomes the input in the third function, which we can call j of x, and then we add by 2. So in other words, this would be our input. This is our output. The output then becomes the input, which we get gives us a new output, and that new output then becomes the input and gives us another new output. So the order in which we would write down that function would be that I have to do j after h after g. So we write that as this little circle here. So this circle means after. So j after h after g means that we're putting our input into g first, taking that output and putting it as an input into h, taking that output and then putting it as an input into j. So you almost like write it in reverse order. So in general, we say that composition of functions is not commutative. So if I was to do h after g, it wouldn't be equal to g after h. Sometimes you might randomly find that that does happen, but in general, it's not commutative. H after g of x is the same as writing it as h after g and then of x, which is also the same way of writing it is put x into g and then put it into h, and that can also be written as hg of x with no circles. So basically all of these mean the same thing. It's just that the question can be written in these different ways. So you have to recognise that this all means the same thing. So they all basically mean that we have to do H after G. So in this diagram down here on the bottom then, what we could see is we can go, of course, from A and input it into B, and then take our answer from B and input it into C, or we can go straight from A to C. So both routes in these functions, the direct route and the route where there are stages, will all give us the same answer. So if you don't get the same answer, you know you've done something wrong. Okay, so let's have a look at an example. Okay, so we're going to look at question 14 on page 132 in your books. And we're just going to take little bits and pieces from this question. So we have a function is defined by h of x equals 2x plus 4. And we have a second function is defined by g of x is equal to x squared plus 1. The function f then is defined as h after g. So what we're given here is we're given the decomposed function. And we want to find, first of all, well, what is the original function? What would this look like if we found f of h after g? So we start by saying, what do I do first? Well, my input goes into g first. So input x goes into g first. And then the output of g goes into, and then the output from g of x would go into h of x. So in other words, what that basically means is that the function f of x is where I'm going to basically take g of x and put it into h of x. In other words, this is my input. So wherever there's an x, we're going to put the function g of x. So hx there is 2x plus 4. So that means that instead of an x, I'm going to put the function g of x, which is x squared plus 1. And then I have to add 4 to it. So we can say f of x is equal to 2x squared plus 2 plus 4. In other words, f of x is equal to 2x squared plus 6. So another thing to note is that that function f of x could have actually been decomposed into two different functions other than h of x and g of x. We could actually say that f of x could be written as, let's say p of x. Well, what am I doing first here to my input? Well, my input is x, so I'm squaring it first. After I square it, I get an answer. And I take that output and it becomes my input in my next function, where I'm going to have to multiply it by 2. And then I take my output and it becomes my input in the next function, which means I would have to add 6 to it. So I would square my input, I'd multiply my input by 2, and then I would add 6 to it. So f of x could also be decomposed by saying we do n after m after p of x. So sometimes there's multiple ways to get the same answer. Okay, so now it says we'll find f of 3. So finding f of 3 is easy, because that means wherever there's an x, my input is going to be 3. So we have 2x squared plus 6. So that means I'm taking my input, I'm squaring it. After I square it, I multiply it by 2. And after I multiply it by 2, I add 6 to it. So we have 9 times 2 is 18, and 18 plus 6 is 24. Okay, so the third one then says investigate, is this commutative? In other words, if I do h after g of x, is it the same as g after h of x? So we've already written down h after g of x. We got 2x squared plus 6. And if we get g after h of x, well, that basically is the same as saying I'm taking my function h of x and it is becoming the input in g. In other words, wherever there's an x, I'm going to put my function hx. So my function g of x was x squared plus 1. So it's something squared plus 1. And what's going into the x squared is the h of x, which is, of course, 2x plus 4. So 2x plus 4 squared means it's going to be 2x to be squared, which is 4x squared. If I take 2x plus 4 and I multiply them and double it, I get 8x doubled, which is 16x. And then taking 4 and squaring it, I get 16. And then I have to add 1 to that. And that gives me 4x squared plus 16x plus 17. So clearly we're getting two completely different answers there. So g after h of x, not the same as h after g of x. Okay, and the last one then says, well, is this an even function? So we're told the definition of an even function is if I input minus x into my function, then I should get the same answer if I input x into my function. So of course f of x is defined as 2x squared plus 6. So if I take minus x and put it in wherever there's an x, well, I get 2 times minus x to be squared plus 6. And of course, minus x to be squared is just x squared. So of course, this is an even function. So we say, therefore, f of minus x equals f of x. Hence, f is an even function. Okay, so we've looked at writing our composition of functions. I've also shown you another way of decomposing the function, and we've looked at putting inputs in and getting our outputs into our composition function. Okay, so in this example here, we're given two functions, j of x and g of x, and we're told that there's a third function that will give us our function f. So we're told our function f is defined as h after g after j. And we have to define the function h for each of the following situations. So the first thing that's important to note is that we can have multiple different answers here. Okay. So what we're told here is that we're inputting 1 into our function f, which is going to give us an output of 12. So my order of operations is j of x, then I have to take my output from j and I'll input it into g, which is x squared, and then I'll take my output from g and I'll input it into h, and the answer I have to get is 12. So we need to know, well, what am I doing to get this 12? So if I take 1 and I input it into j first of all, I'm going to have j is going to be 1 plus 2, which gives me 3. So this is my output from j. That now becomes my input in g. So I'm inputting 3 into g. I have to square that, which gives me 9. And then that 9 is now going to become my input into h. So what can I do to 9 to get to 12? So I could, of course, add 3. So in other words, if I was adding 3, I would get 12. So that would mean that h of x would be my input plus 3. So in other words, I could define h of x as x plus 3. But I could have also said that if I put 9 into h and I get an output of 12, well, I could double 9, which would give me 18, and then I could subtract 6 from that, and I would still get 12. And in that case, then, h of x would be defined as doubling my input and subtracting 6. Okay, so we could try multiple variations of getting my answer. It could be the square root of 9, which is 3, and then that would be adding. So if I got the square root of 9, I'd be getting the square root of x. That would give me 3, and then 3 plus 9 would give me 12. So I could actually have another function, which is root x plus 9, and that would still give me an output of 12. So it's always important to remember that if we start with an input of x and we get an output in these composition functions, that output then becomes your input. So we always write our input as x when we're decomposing these functions. We get an output, that output then becomes the input in the next function, which then gives us an output overall at the end. So let's have a look at some questions. So we're going to go to page 132 in your books. So we're going to do 15, 16, 19, 20, 22, part 3 and part 4.